Welcome to Module 6. In this lesson, we will learn how to match PV arrays to inverters for safe, efficient, and reliable 25-year performance. This diagram compares the string maximum power point voltage range from 650 watt to 850 watt against two invert MPPT windows. Invert A's MPPT window is 500 watt to 800 watt. Its maximum of 800 watt is lower than the string maximum power point voltage maximum of 850 watt. So part of the array voltage lies outside the tracking range and it fails. Inverter B's MPPT window is 600 watt to 900 watt. Both the maximum power point voltage minimum 650 watt and the maximum power point voltage maximum 850 fall within this window, so it passes. Inverter compatibility means the PV array operators safety within the inverter's electrical limits. That indicates voltage, current, and power. If any limit is exceeded, the system becomes unsafe or inefficient. To confirm compatibility, we perform 5 checkers: maximum voltage, minimum voltage, current, power, and the MPPT range. Those 5 checks form the foundation of inverter match. For maximum voltage, we use open circuit voltage at the coldest side temperature, cold with increased voltage. So this is the worst case condition. The result must stay below the inverter's maximum DC voltage. For minimum voltage, we use maximum power point voltage at the hottest temperature. Heat reduces voltage, so this is the lowest point the array will operate. Vmpp must stay above the inverter's MPPT minimum. Next, we check current. String current must be less than or equal to the inverter's input current limit. And remember, all parallel string current should be added together. Power compatibility ensures the array's DC power doesn't exceed the inverter's import rating. Oversizing is allowed, typically 10 to 30%, but never beyond the inverter's limit. Finally, we check the maximum power tracking range. The array's operating voltage, maximum power point voltage, must follow inside the inverter's MPPT window. This ensures the inverter can track maximum power throughout the year. Here we compare the same string maximum power point voltage range 650 watt to 850 watt with two invert MPPT windows. Inverter A's MPPT window is 600 watt to 900 watt. Since the maximum power point voltage minimum 650 watt and the maximum power point voltage maximum 850 are inside this range, is compatible. Inverter B's MPPT window is 500 to 800. Its upper limit of 800 watt is below the maximum power point voltage maximum of 850 watt, meaning the array voltage exceeds the tracking range, so it fails. In this example, all checks pass: maximum voltage, minimum voltage, current, and power. The array is fully compatible with the inverter. Here are common mistakes to avoid: ignoring temperature effects, adding too many streams per MPPT, letting maximum power voltage fall too low at high temperature, and oversizing beyond limits. These mistakes can cause shutdowns or long-term reliability issues. Long-term reliability comes from managing strings: thermal, electrical, mechanical, and environmental. Even when the design is compatible, controlling those stresses is what keeps a solar plant performed for 25 years. Reliability depends on component quality and resistance to thermal, electrical, mechanical, and environmental stress. To improve reliability, use quality components, ensure proper installation, manage heat, and perform regular inspection. Preventive maintenance keeps the plant performing for decades. To summarize, check maximum voltage using cold temperature, open circuit voltage. Check minimum voltage using hot temperature, maximum power point voltage. Verify current and power limits. Ensure maximum power point voltage fits inside the MPPT window. And remember, reliability depends on quality, installation, and stress management. In the next module, we will continue building the system step by step, moving into DC combiner design, string protection, and how arrays connect safety to inverters. If you are enjoying this solar engineering series, feel free to like the video, subscribe to the channel, and share it with anyone learning solar engineering. Your support really helps me keep creating high quality engineering content. Thanks for watching Module 6. We will continue in Module 7 as we move forward in Series 2. See you there.